Hello, hello. Notes on section 2.5, and again we separated this off into two parts. So 2.5a, we're going to solve one-step multiplication and division equations. So you've already looked at how to solve a one-step addition and subtraction equation. Now, multiplication and division. Goal is the same. You want to get the variable alone. You need to find the value of the variable that makes the equation true. So you have to isolate it. You have to get it by itself in order to figure out its value. So take a look at 3x equals negative 12. And I just want you to think for a moment about what you could do to each side to get that x by itself. And generally when we've had this discussion in class, I'm going to kind of, don't write this, don't write what I'm writing right now, but I'll have a lot of people that say, well, 3x equals negative 12, in order to get rid of this, I can just add a negative 3 to each side. If you have 3x plus negative 3, does this negative 3 have an x? No, those are not like terms. You can't combine those. 3x plus negative 3, if I said simplify this expression, that would already be simplified. There's nothing that you can do. So adding a negative 3 isn't going to work. We have to figure out what can I do to get rid of this 3, but adding a negative 3 doesn't do it. And I think understanding this, it will help you to think about the fact that 1x is the same as x. So if you have a 3x, what could I do to end up with 1x? Well, I realize that you might think, okay, well, if I add a negative 2x, oops, I don't know what I did that for. If you add a negative 2x, then you have x. But now guess what you have? Now you have negative 12 plus negative 2x. And now you have more x's than you know what to do with. Just
Never
like, hey,
good.
Jesse on Disney. Okay, so that doesn't work. All right, another way, and now you can write on your paper, so you know that I'm going to tell you the correct way. Another way to get x by itself without creating more x's, just divide the coefficient, divide this by the coefficient of the letter x. So 3x, if I divide this by 3, what's 3 divided by 3? It's not 6, it's not 0, it's 1. So if 3 divided by 3 is 1, that means I have 1x left. And isn't 1x the same as x? Yes! So whatever you do to this side, you have to do to this side as well. So negative 12 divided by a positive 3, one of each means it's negative. 12 divided by 3 is 4. To check to make sure this works, and I'm not just making this up, just telling you nonsense, plug it in. 3 next to x means 3 times x. That's why it's called a multiplication equation, because the variable is being multiplied. 3 times negative 4 means 3 times x should equal negative 12. Does it? Yes! So I wasn't lying. That's exactly how you do it. So the reason that you're allowed to do this is because of the division property of equality. And it says that dividing each side of the equation by the same number makes an equation that's equal to it. So that's why you're allowed the division property of equality. Okay, so all we're going to do now is 4 of this type of equation. These are all multiplication equations because the variable has a number directly next to it, which means multiplication. You have to show your work, even for the ones that you can do in your head, although most of these, they're going to involve fractions and decimals, and I don't know a lot of people that can do those in their head. So anywho, I have 4x equals negative 18. I'm not going to add a negative 4 to each side because this is not an addition equation. This is a multiplication equation. That means I need to divide. I'm going to divide this by the number in front of the x, which is a 4. Notice I didn't change the sign because isn't 4 divided by negative 4 a negative 1? And I don't want a negative x. There's nothing worse than a negative x. Just won't leave you alone. You want a positive x. You want a happy relationship, okay? Working relationship here. So don't change the sign. The number divided by itself is what gives you the 1. So 1x is the same as x. I now have to take negative 18 and divide it by 4. It doesn't go in there evenly. Of course not. That would be too easy. So we're going to do some long division. Negative 18 divided by 4, first off, I know it's going to be negative because when you divide with one of each, it's negative. And I need to take 18 divided by 4. Well, 4 goes into 18 4 times. 4 times 4 is 16. I'm going to subtract. And now maybe you're seeing why we show you all of that information and how to divide with decimals. because now I'm left with 2 and I'm out of numbers. That means I need to throw a decimal point in there, and I need to add a 0. 4 goes into 20 5 times. 4 times 5 is 20, so we're good. So that means that the solution for this one is negative 4.5. To check to make sure that this is right, you would just plug it back in there. 4 times negative 4.5 should equal negative 18. I know that 4 times 4 is 16, and if I have 0.5 4 times, that's another 2. So, hey, it's right. Don't just take my word for it. Do it. Okay, now I have negative 2y equals negative 7 and 5 tenths. I want y by itself. Again, I cannot just add 2. Please don't do that. It's not an addition equation. If I want to get rid of a negative 2 that's being multiplied, I need to divide by that same digit. Only a number divided by itself will give you a positive 1. So a negative 2 divided by another negative 2 is 1, and 1y is y. Now I'm going to divide this by negative 2 as well. So, negative divided by a negative, I'm going to have a positive. And 7.5 divided by 2, let's see. 7.5 divided by 2. Okay, 2 goes into 7 3 times. 2 times 3 is 6. We subtract, bring down the 5. 2 goes into 15. Oh, let me bring the decimal up. 7 times. 2 times 7 is 14. 1, I need a 0 added on there. 2 goes into 10 5 times. 2 times 5 is 10. Yes. So here we go. We have 3 and 75 hundredths, and it's positive because when you divide two negatives, you get a positive. And again, to check this, all you're going to do is go back to your original equation. Take negative 2 times 3.75, and you're supposed to get negative 7.5. I'm not going to do this the long drawn out way. I know you've already learned how to do that, but you can kind of estimate as well. This is a negative times a positive. We know we're going to get a negative result. And if you have 3 twice, that's 6. If you have, let's say you have 75 cents twice, that's like $1.50, right? So 6 plus $1.50 is $7.50. There we go. Beautiful. Estimation skills. Proving that we're right. Okay, negative 20 equals 25 hundredths times n. This time the n is over here. It's okay. There's no law that says it has to be on that side. I would like to make a law that says it has to be on that side.
It makes me very uncomfortable.
I really like it over there, but it's okay. It can be over here.
Sorry.
But remember, we want n by itself. So we're not going to divide by negative 20 because there's no n over here. The n is over here. So we need to divide each side by the 25 hundredths. Okay, so when you do that, 25 hundredths divided by 25 hundredths is 1, because any number divided by itself is 1. N is left alone. Now I need to take negative 20 and divide that by 0.25, 25 hundredths. So let's do that. 20 goes on the inside, and we have 25 hundredths on the outside. I didn't mention this, but hopefully you're saying, oh, wait a minute, Mrs. Trombley, you need to mention that this is a negative and a positive. I'm going to have a negative result. Yes, I'm sure that's exactly what you were thinking.
They were all saying that.
Yes, wait, you must estimate first. Okay, so notice the decimal point out here. It's not allowed to be out here, only in here. So that has to move 2 places over. That means that this imaginary decimal point that was at the end needs to move over twice. So this is really saying 2,000 divided by 25. Woo! Okay, so let's do it. 25 doesn't go into 2. It doesn't go into 20. It does go into 200. I know that it takes 4 25s to go into 100, so that means it would take 8 to go into 200. I'm going to write the 8 right above this 0 because it's representing into this whole amount 200. And 25 times 8 is 200. And bring down the 0. 25 goes into 0 how many times? Oh, 0 with 0 left, and then 0, 0, 0. So our answer is, yes, negative 80. In order to check this, which I don't have enough room, but you will on your homework papers, you can take as much space as you need tomorrow when we're working on this, you would just take 0.25, or 25 hundredths, and you would multiply that by negative 80. And you should get negative 20, and I can tell you, I promise you, it's right.
Yeah, like think of it as if you had 80 quarters. Think about it.
80 quarters.
You'd have 20 bucks.
Yes.
Sam.
Yep. It works. Whenever I see 0.25, I just think about money. It's all about the Benjamins. Okay. Last one of this type, I have negative p equals negative 24. I'll just refrain. There's all kinds of things going on in my head that I would love to say, but I'm not going to say them. Just use your imagination. So negative p equals negative 24. I don't want to know what negative p is. Nobody wants to know that. I want to know what positive p is. So here, you need to recall that when you have just a letter by itself hanging out, it really means you have one of it. So we actually have negative 1p, which equals negative 24. So these mean the same exact thing. How do you get p by itself? Well, in this equation, because it's a multiplication equation, I have to divide by the coefficient. So negative 1 divided by negative 1 is 1. That means p is alone. Negative 24 divided by negative 1 is 24. I do have room to check this one. So negative p, that means negative, and p is 24, should equal negative 24. It does! Yay, we're right. Okay, just when you thought it couldn't get any more fun, we have more. But wait, there's more. Okay, so this one's a little different. This is a division equation. Why? Because the variable is being divided by a number. And that's why it's called that. It makes perfect sense. Question for you is, how do you get x alone in this one? In a multiplication equation, you had to divide. Guess what you do with a division equation? Yes, you multiply. And here's why it works. I will show you. You have x divided by 3 equals negative 6. X is being divided by 3. To undo dividing by 3, I can multiply by 3. So this means I want to take 3 and multiply it by x over 3. And if I multiply that side by 3, that's right, I need to multiply this side by 3. Now, you remember our whole cross-canceling conversation. I'm sure you will never forget it. This really means 3 over 1, right? And when you're multiplying fractions and you see that you have the same exact number across from each other, didn't we say that that's gone? It's like saying 1 and 1, and 1 times x is x, and 1 times 1 is 1, and all that, right? But did you just see what happened here? Don't you now have just x over 1 left? And negative 6 times 3, yes, is negative 18. What's any number divided by 1? Yeah, it's itself. Like if I said, what's 100 divided by 1? You would say 100. And if I said, what's 50 divided by 1? You would say 50. And when I said, what's x divided by 1? I'm hoping you would say, oh, it's x. So yes, x equals negative 18. So this multiplication property of equality states that you can multiply each side of the equation by a number, and it doesn't affect anything. It doesn't change the result. It gives you an equivalent equation. So when you have a division equation, whatever the variable is being divided by, all you have to do is multiply each side by that same amount, and bam, you will have your answer. And you can check it just the same. So here I have n divided by negative 7. I'm sorry, n divided by 3 equals negative 7. I'm going to draw my line so I can separate one side from the other. N is being divided by 3. In order to get rid of that dividing by 3, I'm going to multiply that side by 3. And if I do that, I'd better do it over here as well. So those cancel out. You're left with n over 1. And again, n divided by 1 is just n. You have successfully gotten n alone. A negative 7 times a positive 3 is negative 21. You want to make sure that you're right? Plug it in, plug it in. If n is negative 21, I'm going to replace n with negative 21 and rewrite the rest of what is there. Now ask yourself, does negative 21 divided by 3, because that's what this means, fractions are division problems, yes, negative 21 divided by 3 is negative 7. That means we're right. N does equal negative 21. I'm not a big fat liar making this up. Okay, negative 12 equals y divided by 5. Y's over here. It's allowed to be. It's okay. It wants to be by itself on this side of the equation. So to get rid of dividing by 5, you guessed it, I'm going to multiply by 5. I'm going to do it to both sides so no one gets angry. Those 5's will cancel out. I'm really left with y over 1, which y divided by 1 is y. And 5 times negative 12, do you know your 12's? If not, get your multiplication chart. Do it, do it. And if you don't know them, extramath.com, great practice. Anyway, that should be enough time for you to write down negative 60. So y should be equal to negative 60. To make sure that we're right, go back up to your original. It says that y divided by 5 equals negative 12. So does negative 60 divided by 5 give you negative 12? Well, 5 does go into 60 12 times, and a negative divided by a positive is a negative. So yes, it's right. 2 more. Oh, but now look at, threw a wrench in the plan. There's a little negative sign right there. Now, you may recall me doing a little example talking about if you have negative 10 fifths, it equals negative 2, because it doesn't matter if you put the negative with the top or if you put it with the bottom. If you have a negative, it means that either one of them can be negative. I'm sure you remember this conversation. I remember it because we actually recorded it like an hour ago. We are doing this kamikaze in my basement in the summertime. It's a good time. So anyway, knowing that this negative sign can go with the top or with the bottom, and that you want the x to be by itself, a great idea when you see a division equation like this is to just put the negative with the denominator so the x doesn't have a negative, or the y or the p or whatever letter you're using. So this and this, they mean the same exact thing. So now I'm going to get rid of this negative 3. How, you ask? By multiplying each side by a negative 3. We end up being able to cross cancel those negative 3's. You're left with x divided by 1, which, yes, is x. A negative times a negative is a positive, and 15 times 3 is 45. When we go to check this, it says negative x over 3, so negative 45 over 3 is supposed to equal negative 15. Well, 45 divided by 3 is 15, and it's negative, so we know that we're right. Last but not least, again, here is p on this side of the equation. It's allowed, it's okay. It's negative. That means I'm going to put that negative sign with my denominator so that I don't have negative p. Again, I'm going to keep my mouth closed. All right, I want this negative 10 to go away. It's being divided by negative 10, so that means I'm going to multiply each side by negative 10. Negative 10 times a negative 1 gives me positive 10. Those cancel out. You are left with p. And let's check it. I'm going to plug 10 in for p, and negative 10 divided by 10 is 1, and it's a negative 1, and negative 1 equals negative 1. And you are right. We'll see you tomorrow.